Okay, our next speaker is Patrick. Patrick is a lecturer from UNSW Sydney. So today we'll talk about actual education technology.
Thanks, Hugh. So, thanks for coming today. I'm going to give you a very short talk on a few different tech tools that I use in my teaching. I don't expect you to have heard of any of these. So, in fact, I just ask you quickly to throw your hand. Has anyone here ever heard of Quarto before? Wow, 2 people, 2, 3. Kaggle? Okay, that's a lot more. Okay. What about say GitHub Copilot? Okay, that's more than I expected. So I put a bit too much in my abstract, so I'm mainly going to talk more about Kaggle, more about Quarto, a bit less about Kaggle, and not at all about the AI coding assistants. But just so everyone knows what Quarto is, it's the sort of next evolution of R Markdown, which I think should be quite popular. Kaggle is a website where you can compete with each other in data science prediction tasks. So I'll show you an example later. And GitHub Copilot is an AI assistant to help you finish your coding. So all I'll say about that is try it out. It's very good, very good. So today will be from the perspective of someone who teaches actuarial science, but we'll have some valuable practical parts for our industry colleagues as well. And I thought this would be a gentle, easy talk for this education research conference. Little did I know I'd be the only person to submit an education talk for this whole conference, so I was a little embarrassed to find that. I would have...
praised.
Sorry?
You should be praised.
Well, I would have tried to think of something more profound to say if I'd known that this would be the case, but anyway, let's get going. So what is my situation? I teach actuarial science students in Sydney, machine learning and artificial intelligence. So these are 2 separate courses. Machine learning is more of an introduction, starting with linear regression, building up to nonlinear tree models and unsupervised learning. The AI course that I teach is mainly a deep learning course, one that I've constructed. And the students deal with image and text and time series data, a little bit of generative networks, and from next year, hopefully bring in some reinforcement learning. So to do that, I need to make lecture slides, course websites, and some fun, engaging assessments for them. And in particular, the way that I teach, if I want the students to understand something, I'll show it to them multiple times in different modalities. So if I think I can teach some complicated concept, and I'll use a graphic if I can. Otherwise, it's some real code that actually runs, that demonstrates the concept, or maths or words. So I try to do 2 or 3 of these for each of the difficult concepts. And with that, I think I can make the students understand something, but they won't learn it unless they go off and do it themselves. Right? They have to actually do the assessment, do the data analysis, make the mistakes, then they learn in the long-term memory what's going on. And for that side, the assessment, I try to focus on authentic assessment, that is, using real data, solving real problems, and I don't restrict the students. I don't say, can't use AI, for example. I say, go for it. Do your best. And one point on the here, preferring code to just writing math formulas on slides. With math formulas, you can write any old garbage, and it doesn't need to be true or not. The code, it has the ultimate BS detector in that it either runs or it doesn't run. And I think that's much more useful for keeping errors out of the materials. So just to give you a very basic example, so teaching linear regression. So what I would do is I'd have the same concept different ways. So let's say have that's a boring color. Math first, and I'd have a code chunk here showing in R, in this case, how you run the linear model, and it runs the code, but it gives the output, and then we talk about the output so they understand what's going on. In that case, that's just in 3 modalities: math, code, and then I'll speak to them in the class, so in words. or if I can come up with a useful graphic, usually generated by code as well, I'll use that. So mean squared error, you can visualize the errors by looking at the residuals and drawing a square out of them and adding up those areas. So for example, if you had this straight line for this data, one outlier, well then this curve that gets very close here, to 3 of the data points, it wouldn't like this solution because of the massive squared error it accumulates compared to the right-hand side. So that's what I mean by mixing the modalities. I try to have my resources to be interactive, so I'll show you what I mean here a few different ways. Yeah. Alright, that. Yeah, I can't zoom in. This will have to do. So this is data on mortalities. The blue are the blue dots. Year and age are explaining the mortality, and so I have this 3D plot to show how a simple linear regression is insufficient to fit this mortality data, because if you look down one side, we can see the straight line is not at all able to reproduce the infant mortality spike. So it's a terrible model for this, but it can capture, for example, the decreasing mortality over time. So that's one kind of interactivity in my slides, so that I do it in the class and the students can come to these afterwards and play with them themselves. Or another one is some kind of sliders, so if I'm teaching them splines, they need to choose for some hyperparameter how many knots are in the spline. So they have a slider here to say, okay, what does it look like if I have my linear spline? I add more and more knots, so basic stuff. And one last one is this kind where it's sort of 2 different tabs. So one version here, I use this a lot for showing data science examples in multiple languages. So I teach R and Python where it's possible. And so the students can just tab between them to see, okay, that's how you do the quadratic regression in Python and in R. And so the new code, the new output. Okay, so that's the slide side of things, but connected to them is a course website that is also generated in the same way. So that is so for example, my AI course, I have all of the lecture materials here, all of the tutorials and labs and everything that isn't assessment, basically. I tell the students anything to do with assessment is on Moodle, the LMS. Everything to do with learning is on the course website, and they can pretty easily find what they need. And then there's some nice things they can see where they are in these long documents. They can easily jump between them. They can search for key terms there. Okay, so on to the student feedback I got this year. I was kind of shocked that they really liked this course website that I made. Some just random anonymous student feedback. I love when courses take the time to make their own website and interactive demonstrations, or caps shouting. I really like this website. It's a bit sad to see this fake word in this one, but anyway, I really liked how the course was. Favorite thing about the course was the course website. So the students appreciate it. It seems very basic, to be frank, but the way it's generated is using Quarto. So Quarto is the next step in R Markdown, the sort of a new replacement of R Markdown, if you like. It's easy to get started with. You're basically writing Markdown code. So on the left here is some Markdown, and on the right is what it generates. So hash to make your top level heading, hash, subheadings, dash for the bullet points, and all the basic formatting is straightforward. And it keeps the best part of LaTeX, which is its equation rendering. I mean, every other part of LaTeX is a huge pain to do with formatting and so on. But the only thing that LaTeX is great at is the equations, and they're built in. So you could either memorize those. It'd only take you 5 minutes to learn Markdown. It's not a real programming language. But if you didn't want to do that, it's built into RStudio, for example. You can just treat it more like a Word document. You can highlight something and say, make it bold, or insert a new code chunk. The top part of any Quarto file is the YAML configuration, and that's the part where you change it to say, I want this specific kind of output. Like I want a website, or I want slides, or I want this or that. So if you change what I had before, and just say, give me HTML as a website, then you've got the same, you didn't change any of your content, but you've got a whole new type of output. So I use this all the time for just making websites now. So my personal website is just Quarto generated, it's easy as pie. Recently, I put together all of the research code from UNSW's researchers into a software directory. So that's Quarto generated as well. Very, very easy. And the slides that I'm using today in my lectures are also generated. It's just a different format called the reveal.js. I like it because I think it looks better than other slide engines, but also it doesn't have just slide 1, slide 2, slide 3. It creates a two-dimensional view of your slides. So you can group together slides. And you see this is the overview mode. And so I can easily say, okay, that I'm now in the Quarto part of my presentation. And when I'm constructing the slides, I can see, I'm spending way too long on X, Y, Z topic. And while I'm going through it, I can jump back and forth between them easily. The second part I like about it is that it is a website, the reveal.js slides. So anything you can do on a website, you can do in your slides. So that's a lot when you think about it, but for most practical purposes, I'm thinking animations, videos, or any kind of embedded URL, iframe type thing. So the example I showed you before is you write something once, and then you can change, okay, give me slides or give me a website, and you get the same content in different ways. If you want, you can add more to some outputs than others, and I use this for my course website. I keep my slides as basic as I can, because I don't want heaps of text confusing them. I mean, maybe this looks like a lot of text, but this code I would explain to them, okay, from the last slide, the only thing that changed is line 10, and tell them about that. So I don't think of this as a lot of code. But you can say, okay, if you're making the website version, add in all these explanations here, so which is for line by line what's going on. So this is what I would have said in the class. When they come back to it later, they have kind of, it's almost like an online textbook resource. So you can look up, okay, line 6, this is what this code is doing. Or even basic things, like if I make this plot of this NFIP data set, the floodplains in America, and I make this graphic of where the plains are coming from, it's not important to the students how you make this map, but some 1 or 2% of them will email me and ask for that code, and even I might need it in the future. So on the course website version, I have these little drop-down sections here where it says where the code is hidden behind there, and the interested person just clicks on that and it appears. Okay, this is all the code that was used to generate that. Okay, so I guess the last few minutes of my talk are on the Kaggle competition. So I embedded a Kaggle competition into my class this year, and it was quite interesting. But before that, for those who don't know, it seems like almost nobody, Kaggle's a site where companies come or individuals come and upload a data set and a specific prediction problem, and then sometimes attach some money to it. So, and then people compete to make the best predictions and win the money. And in general, it's a very useful place to find data sets and that are ready and specific data science problems to practice on. So for students. But for us, we could upload our own data, make our own competition for our class. And we did that last term. So we put up we had this data set of people going to hospital in Brazil and whether or not when they had COVID-19 and whether or not they died from COVID-19. There were, I think, 60,000 observations in the original data set. We took 30,000 of them, gave them to the students, and so they could train some models on this. So they had X and Y. They had the covariates and whether or not these Brazilians survived or died. And then we held back the other 30,000 for testing purposes. So the competition was open for some amount of time, a few weeks, I think, for us. And so that's what the data looks like. And then during that time, the students could upload their predictions for the remaining 30,000 people. That we didn't tell them whether they survived or not, but we gave out their covariate information, the X. And so they would upload a file with 30,000, true, false, whether they lived or died. And then Kaggle would calculate their accuracy and rank them publicly. And so some students really got into this. And for example, out of the 300 or so students, there were 13,000 submissions of predictions in this 2-week period. We had students emailing us saying, okay, an upload of 5 predictions per day was the normal limit. That's too few, increase it. So we uploaded up to 20. A few days later, another complaint, 20 per day is too low. Can you increase it? Like, no, that's too much. And it was an element of teaching them proper data science in that response, because they can easily overfit. We know of overfitting the training data. If you have this validation set, you can easily overfit this validation set as well. So what Kaggle was actually doing when it was calculating their score, their public score, it was only looking at a random 15,000 out of the 30,000 test set, telling them their accuracy on that subset. And then at the end of the 2 weeks, it would flip over to the hidden 15,000 that the students never saw, never had their predictions evaluated on. And when the competition ended, they were re-ranked based on their accuracy there, so they couldn't overfit the validation set. And in fact, the guy who won here, Sebastian, he was ranked number 30 in the class on the public set, and then jumped 30 places up. So we gave them some score based on their accuracy, and we gave them some bonus marks just to participate during the 2 weeks of the competition. And I think the students had a lot of good things to say about it. So again, more student feedback. Well, the best thing about the course, Kaggle was so good. I was checking every couple of hours to see if I could overtake it. Okay, so I'll end at the 19-minute mark. So going back to the resources for Quarter, if you wanted to try it yourself, I highly recommend it. The Quarter website is really fantastic, well written, lots of detailed examples. I have, if you're a UNSW person, I made a template. This is the one I'm using here, the UNSW one. So you can just use that in a whole long video explaining how to set this whole thing up. But onto the conclusions. My first one is that if you use Beamer for your presentations, just please don't. Moving on. If you haven't made a website ever, maybe, easy to do, then give Quarter a try and just try to make one. It's really quite simple. And there's heaps of applications. And then I'll end on this one. Is a challenge, actually, and that is next time that you go to present at a conference or your students, try one new thing, different. Try one new technique or tool or idea, and just see how it goes. It's usually a lot of fun. So thanks very much for your attention.
Thanks, Patrick, for the very useful presentation. Any questions?
How did you create that 3D graph?
3D graph.
Yeah, the one in the middle of your presentation, the mortality.
That's a good question. I'd have to look it up, to be honest, because I do it so rarely. It was some art package. Plotly, I think it was. Art probably package now.
Yeah, cool.
Yeah.